Welcome to Modeling Trig Functions, Example 2. In this problem, we're going to graph or find the sine function and cosine function of the graph given above. Remember the vertical shift, we're going to have to take our maximum plus our minimum divided by 2. So what we're going to do is take the 2 plus the negative 2, all divided by 2, so that answer is 0. This means the midline is going to be the x-axis, or y equals 0. Next, the horizontal phase shift. So for a sine function, it's going to start at 0, 0, and the graph ends at 4 pi and 0. So the sine graph starts at 0, where it originally starts at, so there is no horizontal shift. This means that the C value is equal to 0. Next, the amplitude. The amplitude, we're going to have to take our max minus our min divided by 2. So we're going to take 2 minus a negative 2 and divide it by 2. That means it's 4 divided by 2, or just 2. This means the amplitude is 2. That means also that if you go 2 units up from the midline, that's the maximum height, and 2 units down from the midline, that's the minimum height. Let's see. Next is the period. The period is the length of time it takes to complete a cycle. So remember, it's going to be 2 pi divided by the period. So the length of the time it takes to complete one cycle in this graph is 4 pi. So 4 pi minus 0 is going to be 4 pi. So our period is 4 pi. So we take 2 pi divided by 4 pi and reduce it. So that's going to be 1/2. This means B is going to be 1/2. So now we have our vertical shift. D is 0. C is 0, A is 2, and B is 1/2. So our equation. So remember, our fundamental equation is going to be y equals A sine of B times x minus C plus D. So that means our function is going to be y equals A in this case is 2, sine of B is 1/2, x minus C is 0, so it's just 1/2 x, and then plus 0, so it'd be y equals 2 sine 1/2 x. To find the cosine function. So the cosine function, again, the vertical shift is going to be the same, is going to be d equals 0. There's no vertical shift. There's no the horizontal shift now, though. So remember, the cosine function starts up at the top. So this is going to start at, well, let's see. If we look at that unit here, that should be at pi and 2. And it's then going to end at, and you can kind of see over here that it would be at 5 pi and 2. So this is going to have a horizontal shift of pi units. So there is a shift to the right pi units. So that means it's going to be positive pi. That means C is pi. Next, our amplitude. Our amplitude is going to still be the same, so A is 2. Now the period, again, is still going to be the same, so B is 1/2. And now if we put this all together, it's going to look like this. Y equals 2 cosine, and with the 1/2, it's going to be 1/2, and then it's going to be x. And then remember, C is pi, so it has to be after the subtraction sign, so it's x minus pi. Let's double check our answer in Desmos. So let's go ahead and bring up Desmos here. So in Desmos, we're going to first type in the first one, which is y equals 2 sine of 1/2 x. Put in parentheses 1/2 x. And the next one is y equals 2 sine, or sorry, cosine, and in parentheses 1/2. And then it's going to be x minus pi. So you can see they're the same graph. So let's see if they match up. So at 0, 0, we said it was pi and 2. We said it was 2 pi and 0. If we kind of scoot along here, we can also then see it's going to be 4 pi and 0 and 3 pi and negative 2. So indeed, it does match our graph from before. I'm going to try and put them side by side so that you can see the graphs matching up. So you can see that it is the same graph in this problem. Pi over 2 and 0. We said it was 4 pi and 0. And if you want to look at the other points, you can.